Hello, everyone. I'm Kundan Vyas. I'm part of the product team here at Stream Native, and I focus on functions, connectivity, and compute-related infrastructure. I also focus on tiered storage. Today's session is primarily about Lakehouse Storage, so let's get started. So I'm really excited about today's session, where I really want to talk about the journey of storage in Apache Pulsar. So as we look into the evolution of storage within Apache Pulsar, I want to actually start right in the beginning. Back in August 2016, that's exactly when the first version of Apache Pulsar was launched. And the creators of Pulsar want to make sure that they contribute to the architecture based on a lot of these learnings from the cloud computing world. And one such learning there was really there are a huge set of advantages in separating the storage from compute, right? So that was a very first thing which was kept in mind. So let's take a look at some of those details here as to how our founders kind of wanted to make sure that the storage and compute were separate and what sort of benefits it really offered. So before that, I want to quickly introduce you to two core components of our Apache Pulsar stack. So the compute layer and the storage layer. So brokers are really responsible for processing all the data which is going in and out of Apache Pulsar, right? This is really the compute layer. And Apache Bookkeeper is really the storage layer. This is the persistent storage layer, which stores all the data which comes into Pulsar, right? So now these two layers are important because I think a big part of our conversation today is about storage. And these layers are designed to be very independent of each other. So that definitely offers a lot of advantages within the Pulsar architecture, right? We basically, all our customers essentially who want to adopt Pulsar, they can scale their compute and storage layers independently, right? And particularly even about performance. If you want to fine tune performance of each of the layers, you can do that without impacting, the other layer. So there are a whole range of advantages which, this architecture offers primarily because the storage is separated from compute. So while Apache Pulsar started getting some adoption, a lot of customers started using it. One thing a few of those customers started running into was high storage costs. Basically, a bunch of customers really wanted to retain data for longer durations of time. And this is primarily for use cases like, compliance or historical analysis, or even for event sourcing, where there are times when they want to play back the old data again. For all these situations, the customers wanted to retain data for longer durations of time. And that started costing them a lot, right? Because typically persistent storage is more expensive than the low cost storage, which is available out there. So that was one of the biggest challenges. And then, of course, there were a whole range of other impacted challenges associated with it. So while thinking about some of these challenges, basically the founders of Apache Pulsar wanted to think about the next stage. So the next stage of evolution here was about solving these problems, right? The problems of storage costs and the growing volume of data causing that, right? So the tiered storage capability was introduced in June 2018. This was really focused about, solving these problems. So let me give you a quick overview of tiered storage of Apache Pulsar. This is a part of the open source technology. It was launched in August 2018 and part of Pulsar 2.1. So the main thing which this capability offers is it takes the data which is getting streamed continuously into Apache Pulsar and offloads that into a tiered storage, which is a low-cost storage, something like an S3 or Google Cloud, or even something else which is being used within your data center, right? Now, typically there are three types of data. There's the hot data, which is in the memory, and there is the warm data, which is within the Apache Bookkeeper, which is the persistent storage. And then there is the cold data, which is very infrequently accessed. And that type of data, it makes sense to store that in something cheaper and access it only when needed. So Apache Pulsar tiered storage really offered that capability to our customers, where it allowed them to offload the data which is not frequently used and put that in a cheaper, low-cost storage. So tiered storage was great, but I think the idea was to continuously keep an eye on what type of improvements could be offered on top of tiered storage. So our team was constantly looking at different types of improvements which could be offered on top of tiered storage to make it more efficient. So that's when in June 2021, a new improvement was proposed. And this was really to basically address a bunch of issues which the first version of tiered storage had. It was about making it more efficient and making it faster. So segment-based data offloading is the improvement which was kind of proposed back in June 2021. And this, let me make it clear here, this is currently still work in progress. This is not fully delivered, but I just want to highlight this because this is one of the many things which was kept in mind during the journey, during the evolution of storage-related improvements while building out these capabilities. So segment-based data offloading basically takes the data which is stored in ledger and breaks it down further into smaller chunks. Each chunk is called segment, and it can be grouped based on time or it can be based on size. And each of these segments can span across different ledgers as well, right? So this is still a work in progress, and we hope to deliver that over time. But I think just want to highlight this. This is something which was kept in mind as well. Now, Apache Pulsar tiered storage was great. A lot of customers still use it, and it works for most customers. But one of the key things here is a lot of use cases started coming up from our customers where they highlighted as about situations where the data just won't, the data journey won't just end in an offloaded state. Oftentimes, customers want to do more with it. They want that data to be discovered by third-party tools so they can learn about it, discover it, they can query it and do more things with it, right? So that was a challenge here. The tiered storage capability in our open source technology within Apache Pulsar only stored data, the offloaded data in a format which was understood by Pulsar, right? It did not offer any type of integration with third-party tools, so which was very limiting for our customers. And there was no support for Lakehouse formats. Lakehouse formats like Delta Lake, Apache Iceberg, and Apache Hudi, these are very popular now. I think most companies, larger companies, are standardizing for one of these formats, and I think they expect the data to live in one of these formats, so it is easier for them to have their tools talk to them, right? So this was some of the gaps, and just thinking about these limitations, we started working on the next stage of the evolution. And back in November 2023, basically Stream Native announced the Lakehouse Storage support. This was a premium set of capabilities within Stream Native Cloud, which basically had a vision of addressing a range of gaps or limitations which the open source tiered storage had, right? And let's take a look a little more on those details. So Lakehouse Storage was introduced back in November. Again, just to give you a quick overview on that, essentially, this is a core capability within Stream Native Cloud. Lakehouse Storage is something which allows customers to offload the data, just like tiered storage, the open source tiered storage, but in a format which is clearly understood by a lot of third-party tools. So users can offload the data in either Delta Lake format, Apache Hudi, or Apache Iceberg format. The way this works is you can, within Stream Native Cloud, enable tiered storage at a namespace level. And once you do that, all the data which is stored, all the topics which are under that namespace, they offload the data automatically to the mapped, low-cost tiered storage. And then you can, once the data is stored there, your third-party tools can directly access that data in the format of their choice, right? Now, let me just highlight a couple of things very quickly here. We have three types of offerings within Stream Native Cloud. We have Stream Native hosted, bring your own cloud, and private cloud. So currently this capability is in private, it has been in private preview, and now we are announcing this to be in public preview. It's going to provide access to the data in Delta Lake format. And our bring your own BYOC customers, the bring your own cloud customers, and private cloud customers they have direct access to their buckets anyways, because the product is running in their tenancy. So they will be able to use the third-party tools like Amazon Athena or Trino to query that data. But for our hosted cloud customers, right now they cannot access this bucket because the storage bucket lives in stream native clouds tenancy. So for them, over time, we're going to expose a catalog, which is going to let them access that data through the catalog, and so that third-party tool can query the data through the catalog, right? So that's mainly for the hosted customers. One last comment on this quickly. This capability of Lakehouse Storage supports both stream read and batch read functionality. So it's supported for both streaming and batch processing use cases, which is pretty important. All right, so there are lots of benefits which for Lakehouse Storage, but I'm just going to touch upon one or two. The first one being a key one. Like if you remember a few slides back, I was talking about the challenges of some companies who wanted to retain data for a longer duration of time. I think this addresses that challenge, mainly because it not only stores the data in a cheaper option, which allows customers to kind of retain there for a longer time, but also in a format which then is completes the life cycle or the journey of the data, because then the third-party tools can talk to that data, right? Besides that, if I were to pick one more benefit here, I think I want to talk about the schema evolution. That's usually a challenge. It's very common that as the data starts getting ingested into different types of streaming technologies, very often the schema changes over time, and then that usually breaks all the pipelines. So the Lakehouse Storage really provides that out-of-the-box capability to kind of evolve the schema as that changes. And this is pretty important for a lot of customers, right? So just a quick preview on the releases. We launched private preview for Lakehouse Storage back in November 2023, and it provided Delta Lake capability. And today we are announcing, we are in May 2024, we are announcing public preview, which is going to provide all the capabilities of private preview, also provide a self-service experience to enable Lakehouse Storage at a namespace level. And then you basically can access the data in Delta Lake format today. And for BYOC customers and private cloud customers, they can consume the data through their third-party tools very much, right? So let's go further. Now I want to quickly cover a demo to just highlight some of these capabilities of Lakehouse Storage I've been talking about. So let me just explain the flow very quickly. So we have a Pulsar producer client here on the left, and which I'm going to be running to populate data into a topic. This topic called My Topic is a part of my namespace, which is enabled for Lakehouse Storage. So what that means is every topic under my namespace will offload data automatically to a storage bucket, which is mapped to the namespace, and it'll be in a Delta Lake format, right? And then I will also show you the data once it's moved to the storage, followed by a quick query, which I'm going to run in Amazon Athena. I'm going to mount an external table, Delta Lake table, and then be able to run query on top of that, right? So let's take a look at this demo real quick. So once you're in Stream Native Cloud, we'll create a new topic. This is the My Topic I was referring to. This is going to be an empty topic right now, so there's no data in it, right? So let's populate some data into it by running a producer client. So I'm just running a Java producer client here, which is populating a lot of data into the topic. And once the data is populated, let's go look at the topic here. You will notice that my topic now has some data in it. So let's go inside the topic to discover that a little more. So there's some throughput going on here, and also you notice there are some producers, consumers, and subscriptions showing up there, which is great. And once you navigate to overview, you'll see a section called offload. This is automatically created subscription to offload the data, right? Once your tier storage is enabled, this automatically gets created. Let's go inside the partition, and this is where you'll notice various details. Let's go to the stats. These stats will be important for some of the developers or operations people. Let's zoom into this a little bit. You'll notice that it highlights all the attributes which talk about the amount of data which went in and out of the topic in terms of bytes, in terms of messages, whether it's in or out, right? And if we scroll down a little more, you'll notice that there's a section here called subscriptions, within which you'll find that offload subscription, which automatically got created after the Lakehouse Storage was enabled. So this will tell you how much of data is offloaded now through the bytes out counter, right? And the number of messages which are offloaded as well. If we scroll down a little more, I just want to highlight some more details. So there is a consumer associated with that subscription, right? This is really taking all your data and offloading it. So some more details in terms of the stats. All the data which in the topic is broken down into different ledgers, right? So each ledger has a certain amount of entries, and then some of these ledgers are offloaded already. Some are in the process of getting offloaded because there's still a continuous stream of data which is flowing there from the producer application. You'll notice some more details here, like the read position and the mark delete position are highlighting, they're pointing to like one of the last ledgers which was created, which means that data is now getting populated into that. Once that's closed, then you'll see some entries in it, right? So now let's navigate to the S3 bucket where the data is going, and there I can quickly show you the format of the data. So I think I'm going to switch to that just in a second, and you'll be able to see the Delta Lake format there. So this is the bucket which is tied to the namespace, which is enabled for Lakehouse Storage. And under the public default and my topic, you'll find all kinds of data here. So the data is in Parquet format, and it is basically Delta Lake format, which will be understood by third-party tools. Let's go to Athena. And now here I'm mounting an external table which points to that Delta Lake folder, the S3 bucket. And you'll notice that my Delta Lake table is now showing up, all the schema is showing up there. Now I'm ready to run some queries associated with this data within the bucket. So just like any other SQL query, I can query and describe the data which is in the bucket. This is all the offloaded data from Lakehouse Storage. And I can run any type of queries as well, right? So this is pretty powerful because all the data which is offloaded via Stream Native Cloud through Lakehouse Storage is now accessible in an open format for third-party tools to access it, right? So this is more like an out-of-the-box capability without running any pipeline. It's pretty powerful. So that was a quick demo here. I'm going to move on to the next slide now. So I want to talk a little bit about the future, right? I think some of the enhancements which are coming up in the future from the Lakehouse Storage side, there are two main categories of enhancements. The first one's really related to Ursa engine. Ursa engine is something which you'll learn more about in hopefully in the EMEA Pulsar keynote. So when you get a chance, if you haven't really seen that, you should go and check out the EMEA Pulsar keynote for May 2024. Basically, here we are continuously keeping an eye on what sort of improvements we can do. I think there are ideas of removing the Apache bookkeeper and basically having note here and streaming the data directly to a lakehouse. That simplifies a lot of things for our customers. So you'll hear more on that side in the future. And just coming to the Lakehouse Storage enhancement side, you will see we're basically focusing on delivering on the vision, which we started talking about last November. So right now we are supporting Delta Lake. In the future, you will see support for Apache Iceberg, Apache Hudi formats. And for our customers who cannot have direct access to their storage buckets, the ones which are in our hosted environments, they can access that data through a data catalog in the future. And then we're also thinking of introducing a new pricing for our Lakehouse Storage, which will be hopefully providing more cheaper pricing for our customers to save more costs on the data storage, right? So let me conclude this session very quickly. Again, just to cover two quick points here. Stream Native, you must have seen through this session across these different topics I covered today. Stream Native is committed to keep an eye on different types of improvements which can be done within the storage layer, and then which are constantly available to our customers in the form of different type of capabilities. There's also new set of capabilities which are planned around Lakehouse Storage, like the data catalog, which will basically help expose the data within our storage bucket to third-party tools, and hence providing a complete, helping the customer complete the data journey and make the most out of the data which is in the offloaded state, right? So yeah, that's something which I wanted to conclude for today's session. Hopefully you found that helpful. This was a quick journey of how Stream Native Lakehouse Storage or the tiered storage capabilities have evolved over time, and then you'll hear more from us in the future about the upcoming capabilities. Thanks everyone for watching this session, and stay tuned for more updates on Lakehouse Storage for the features which are coming up in the future. Thanks again.